From the previous part of the question, we have this over here. And if I were to integrate the left-hand side from 0 to 1, I will be getting x e to the power of 2x from 0 to 1. And we have to do the same thing to the right-hand side, which will be integration from 0 to 1 of 2x e to the power of 2x plus e to the power of 2x dx. Over here on the left-hand side, if I were to substitute 1 in, I will have 1 e to the power of 2 times 1. Minus substituting 0 in, it will just be 0 entirely. This, I'm going to break it up into two different integrals. For the left-hand term, it is going to be 2 integration from 0 to 1 of x e to the power of 2x dx. And for the right-hand term, it is going to be integration from 0 to 1 e to the power of 2x dx. So over here on the left-hand side is e to the power of 2. This is equal to 2 integration from 0 to 1 x e to the power of 2x dx, which is actually what the question wants us to find. Then this, if I were to integrate, it will be 1 over the coefficient of x, which is 2, then e to the power of 2x from 0 to 1. E to the power of 2 is equal to 2 integration from 0 to 1 x e to the power of 2x dx. And this, if I were to substitute 1 in, it is going to be half e to the power of 2. And if I were to substitute 0 in, it is e to the power of 0, which is 1, so minus half. Let's make this the subject. That means 2 integration from 0 to 1 x e to the power of 2x dx is going to be equal to, I'm going to shift this over to the left hand side. It will be half. Then shifting this over to the left hand side, minus half e to the power of 2 plus e to the power of 2, which is, if I were to combine this together, it is going to be half plus half e to the power of 2, which is 1 plus e to the power of 2 divided by 2. So what the question wants us to prove is actually over here without the 2, which means that integration from 0 to 1 x e to the power of 2x dx is going to be dividing the 2 over to the left hand side, 1 plus e squared divided by 4. And this is what the question wants us to show.